Okay, let's look some more at these special products of binomials. Remember when you were a little kid and your teacher made you learn multiplication and you had to draw a little picture? Like this picture is 4 times 4. And so you had 4 across here and 4 times down here, and you could add all these 4s together, 4 plus 4 plus 4 plus 4 would be 16. Or you could count all the little boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You remember having to do that? We all had to do that in elementary school. So now we're going to look at something else we did in elementary school, because this is going to help us with what we're going to do with when we have perfect square trinomials. Okay, so your teacher would also say, well, what if I made this bigger? What if I wanted, instead of 4, what if I wanted to go all the way to 5? Oops, that pen doesn't write. Let's try a different one. What if I wanted to go all the way to 5? So I had 4 here and I added 1 more here, right? And then, so this whole thing would be 5. And then I'd go 1 more down here, so I'd make it 5 times 5. And so I could draw it out like this. Not a very straight line, but you get the idea. And so I have another square. It's still a perfect square. And this is now this one. I put those together. And now this is 5. So I would say that I have 5 times 5. And this whole square would be 25. 25 squares. And so that's how your elementary school teacher probably talked to you about how you would multiply when and how you could make a perfect square. They probably did other things, like they might have done say 3 times 2, and you would see that was 6. But when it was multiplying the same number, it was a square, and they might have called it a perfect square. So let's look at how that works with some of our other, some of our special products. Okay, let's say we have this square right here. And this square is going to be A. That's how long this side is. And this square over here is also A. And because it's a square, all the sides are the same. So this would be A right here. This would be A right here. All the sides are A, right? Now, let's say that we wanted to add some more to that. We wanted to make a bigger square. So we wanted to add B to it. So this is B, and it's B on this side. And then we wanted to add B over here. So this length is A, and this length is B right here. So we could label both of these sides B, right? Now, how long is this side? This side is the same as right here, so that's A. I can label all 4 sides. And this side, because we know of this one, these are A. But if I wanted to make it a perfect square, like I did with the plain number ones like you did in 3rd grade, then I'd need this little thing to make the whole thing a square. Now this is B, and each side of this is B, right? Okay, so this whole side, if I were going to look at this whole side, this part is A plus B. That's the entire side from here all the way to the end, right? This one is A plus B, and that's this whole side here. So if you multiplied A plus B times A plus B, that's where you get A plus B squared. So how do I see that I get my special polynomials? and the product of these perfect squares. All right, so if I would have to add up all four of these, the area of all of those, to find out what this is equal to. So if I have this first square, we do length times width, or base times height, and that gives me a squared, right? So this equals a squared. Now what about these two? These are the same, and they are a times b, so the area of this one is ab, and the area of this one is also ab. So together so this was a squared, and then we had plus two of these, 2ab. Now what do we have left? This little square, its area is b squared. So we would add b squared. So this is how we get a squared plus b squared equals a squared plus 2ab plus b squared.